Students, in this lecture, I will discuss about single phase full wave controlled rectifier. Sometimes it is called two quadrant converter. Okay, so today I will discuss about single phase full wave controlled converter. Depending upon the type of the SCR configuration, single phase full wave controlled rectifier are classified into two types. They are midpoint type converter and second is bridge type converter. Now I will discuss about single phase full wave controlled rectifier with midpoint type for R load. So first I will give the circuit, I will give the description about circuit. So say in this case of midpoint type, two thyristor and a single phase transformer with center tapped secondary are required. Two separate gate signals are required to turn on the thyristors during each half cycle. Thus, these are also known as two pulse converters. Its operation principle may be explained in different modes like first mode like during the positive half cycle of the supply voltage, thyristor T1 is in the forward bias condition, okay, and thyristor T2 is in the reverse biased condition. During this cycle, terminal A is more positive with respect to terminal B. When a gate signal is given to thyristor T1, it starts conducting and the load current follows the path A T1 R load and N, like this path A T1 R load N, okay. This current continues to flow through load as long as the thyristor T1 is in the conduction state. At the instant omega t equal to pi, the thyristor T1 gets turned off as the load current passes through natural zero. Okay, so this is mode 1 operation. Okay, in the second mode, during the negative half cycle of the supply voltage, the terminal B is more positive with respect to terminal A. Thyristor T2 is in the forward bias condition and thyristor T1 is in the reverse bias condition. When the thyristor T2 is triggered at some angle like omega t equal to pi plus alpha, the thyristor T2 is in the conduction state. Okay, now the load current flows along the direction B T2 R load then N, okay. Its load current direction is same as that of the previous mode load current direction, okay. In both half cycles of the supply voltage, thyristors are triggered at the same firing angle. Hence, they share the load current equally, okay. So in this way, the single phase full wave controlled rectifier with midpoint configuration occurs and its associated waveforms are like this, okay. So this is the circuit description and waveform. This is the circuit description and waveform of the single phase full wave controlled rectifier with midpoint type for R load. Now I will discuss about single phase full wave controlled rectifier with midpoint type for RL load, okay. So see, during the positive half cycle of the supply voltage, the polarities of the terminal P and Q are shown in this figure. Okay, T1 is in forward bias condition and T2 is in the reverse bias condition. Give the gate signal to the thyristor T1 at omega t equal to alpha. The load voltage traces the supply voltage and the load current follows the path as like P T1 RL load then N. When omega t equal to pi, supply voltage is 0 and load voltage is 0. But the load current is not 0 because of the presence of load inductance. The load current decays at a point beta, which is shown as extinction angle. In RL circuit, the current waveform is continuous when alpha is less or equal to phi and conduction angle gamma greater or equal to pi, where phi is known as load power factor angle. Okay, so phi is known as load power factor angle, and this is defined by tan inverse omega L by R. Hence, each SCR conducts for a period of pi radian. Okay, the current waveform is discontinuous when alpha is greater than phi and gamma is less than pi. The continuous and discontinuous conduction load current depends upon the value of the load inductance. Now see the second mode of operation. So during the negative half cycle of the supply voltage, the polarity of the Q terminal is more positive with respect to the P terminal. Give the gate signal to the thyristor T2 at omega t equal to pi plus alpha, and the load current follows the path like Q T2 as load RL load then N. Its direction is same as the direction of the load current in the previous mode. Each SCR is subjected to a reverse voltage of 2 EM under the reverse bias condition. It is obvious from the waveform that compared to the half wave converter, it has reduced ripple. Okay, so this circuit's associated waveform for different firing angle is shown like this. Okay, so see, for continuous conduction mode, each SCR should conduct for a period of pi radian. Okay, so single phase full wave control rectifier with midpoint type R load and RL load I have discussed in this lecture. Okay.